Exploring the Solar System Part 2, Spacecraft. How do we get from here on Earth to other points around the solar system? What do we do when we get there, and how do we get the images back again once we've visited these various places? And what does the future hold for future exploration of the solar system? I thought I'd start by thinking to myself, well, how many spacecraft have we sent out into the solar system? And I sort of tried to start counting up on my fingers, and then ran out of fingers, and then realized the total number of spacecraft that have actually been launched on Earth is actually quite large. I know you can't read the individual words, but you get an idea of how long the list is. The last one there in the bottom right is Europa Clipper, which was launched just a few months ago. So there are many, many hundreds of spacecraft that have been launched into the solar system, either to study local areas or to study distant planets. Getting to Mars is not so difficult. If we think about the orbit of Earth and orbit of Mars, this is not to scale, then in order to get from the Earth to Mars, we can fly there on an elliptical orbit. Neither the orbits of Earth or Mars are actually circular, but if we just take this cartoon at face value, we can fly in an ellipse from Earth to Mars, and it's a reasonably efficient way of getting from one planet to another, as long as the planet isn't too far away. But back in the 1960s, it was realized that if we want to explore the rest of the solar system, what about beyond Mars? What about Jupiter, Saturn, Uranus, Neptune, etc.? It was realized that you can actually use a slingshot, a so-called gravity assist. And here we see a spacecraft flying past Jupiter, getting an assist in order to fly on to Saturn. This is the Voyager spacecraft, Voyager 1, launched back in the 1970s. This was also used for Voyager 2, and there, Voyager 2 was launched from Earth, and then it got a slingshot, it got an assist as it flew past Jupiter, which flung it on towards Saturn. Notice there's a dog leg at Saturn. Saturn again was used as a slingshot to give it yet more speed and send it on towards Uranus, and then Uranus gave it another slingshot towards Neptune. So it was possible for one spacecraft to visit 4 planets because they were all lined up in such a way that it was possible to slingshot from one to the other. This was calculated in the 1960s and actually implemented in the 1970s. It meant that you could get there a lot faster, but most importantly, it meant you could get there cheaper because you don't need to use as much fuel. You don't need to send a huge rocket to fire the engine once you've passed one planet to get you to the next planet. You use the planet itself to slingshot to the next one. And because you have less fuel that you need, you can put on more scientific instruments for a given mass of whatever you're launching into space. So it's a very effective way of exploring the outer solar system. When you get to the remote destination, you might want to do scientific instrument measurements of temperature or pressure or magnetic field or something else, but most people are interested in what does it look like? So you want to take an image. This is a very early image of, anybody care to guess what it is? Yes, very good. It was taken by Luna. So this title tells you that this is the far side of the moon. This is 1959. And when you think about the technology available in 1959, no digital cameras back then. So this was basically, that's just the same thing with a little bit of image processing to get rid of some of the noise. Back then, it was acquired not with digital technology, but with film. You remember film? Yep, it was exposed, the film was exposed, and then on board it was developed and fixed and dried and then scanned by a cathode ray tube spot going backwards and forwards, scanning across the negative. And then the output from a photomultiplier was transmitted back to Earth, where they reconstructed the image. Effectively, it was like a fax machine. The image was scanned, sent to Earth, which then generated the image. For comparison, there's a much more recent image taken from Lunar Reconnaissance Orbiter, and you can see, despite the fact that the resolution is better on the LRO, all of the features are basically right. So that was a genuine, well-exposed image of the far side of the moon. That's the first time we realized that the far side of the moon looks quite different to the near side of the moon. It wasn't until the 1960s that we've got digital technology. So for those of you who think that digital cameras are a relatively recent invention, bear in mind the world's first digital camera was on Mariner 4. So yes, it's taken a little while before these digital cameras ended up in your phones, but they started in the 1960s on spacecraft, and then they developed and got smaller and smaller until they're now small enough to go into a mobile phone. So when spacecraft like this pass a planet, the camera is taking data, and that's recorded onto tape, or it was recorded onto tape originally. And once the flyby of the planet had taken place, the tape is rewound and then read and then transmitted. That information is then transmitted back to Earth to generate the images. Again, a little bit noisy to start with, but we can process that out to improve the images. Most of the solar system, or at least most of the major bodies of the solar system, have now been visited. We've also visited a few asteroids and other objects as well. Again, no time to talk in detail about all of the missions that have gone to all of the planets, but let me just pick out a couple of interesting ones. Cassini, for instance, visited Saturn in 2004 to 2017. It ended its life by being crashed into Saturn. Why did they crash it rather than just let it power down? Well, again, for the reasons we said earlier, it is possible that life exists out there. It is possible that some of the moons of Saturn harbor life. Therefore, we didn't want Cassini to accidentally crash into one of these moons and contaminate them, so the spacecraft was crashed deliberately into Saturn at the end of its life. I'm not going to talk through all the numbers, but it is pretty amazing. Just, for instance, 5 billion miles here. It's American, so they're in miles, not kilometers. 5 billion miles traveled for a mission like this. You can get an idea of the scale from the bottom right. There's an average human standing next to the Cassini spacecraft. If we think about what we can see of Saturn as seen from Earth, there's a nice Hubble picture showing a lot of nice detail on the surface of Saturn and in the rings. But if we zoom in on the rings, we can see so much more detail when we've got a spacecraft close to the planet. And this is the amount of detail that Cassini can see in the ring system. Not only detail within the rings, but also which moons are shepherding the ring system into the structures that we see. From different angles, Cassini was there for quite a few years, taking lots of images of the planet and the rings and the moons. It ends up looking like an LP. When you look at it like this, you have to remind yourself that it's a huge system, 250,000 kilometers in diameter, but it might only be a few meters thick. It is the thinnest object in the solar system. It's effectively a few trillion tiny particles of ice-covered material, or possibly ice itself, all independently orbiting Saturn. When the sun is at the right angle coming in during the equinox in the ring plane itself, then the rings themselves still look flat, but there are some regions, some little parts of the ring system that seem to be a little bit mountainous because they cast shadows when the sun angle is very low. And it's thought that these are perhaps kilometers in height rather than a few meters in height. One perspective that we can't get from telescopes on Earth is what does Saturn look like when you're in Saturn's shadow. So this is looking back with the sun backlit, or Saturn backlit with the sun on the other side of Saturn. So you can see here the rings are looking very bright because the sun is shining through the ring system, and we get a different bit of information compared to the sun effectively looking over our shoulder on a ring system. By having the sun shine from behind, it scatters light differently, and we can learn more about the structure of the ring system. In addition to Cassini itself, there was an interloper, a stowaway there called Huygens, which hitched a ride and was launched into the moon Titan. Titan is the biggest moon of Saturn. It's got a very thick atmosphere. It's made of nitrogen. There's a lot of methane on the surface. When Huygens entered the atmosphere and took pictures as it went, it saw a landscape which was not that dissimilar to Earth. There appear to be mountains. There appear to be rivers and lakes. And it looks like there are clouds and rain. Not necessarily water. It's probably more likely to be methane and a few other products. But it looks like we have a structure. It looks like we have a world there. Even though it's at a huge distance away from the sun, it looks like we have a world which is analogous to the world we see around us, as I say, with geological structures that we recognize, like mountains and lakes and rivers and clouds, etc. So another world that we need to explore in more detail. Another system explored Jupiter was explored by a number of different spacecraft, the most recent of which was Juno, back in 2016, nearly 10 years ago. Again, a whole load of numbers there about how far it's traveled, how many million commands have been executed by the spacecraft under mission control. If we have a look at Jupiter and unwrap it, so that's what Jupiter looks like, but if we imagine taking a sphere and unwrapping it so we see the cloud system, we can ask ourselves, where do all these colors come from in the banded system of Jupiter? We think that probably the brightest things are ammonia, but people are now contesting whether or not these are actually ammonia ice in these upper atmosphere clouds. It looks like some of the colors we can see are probably the result of elements like sulfur and phosphorus, and we have to ask ourselves, where are they coming from? To understand the entire cloud system, the storm systems, the weather systems, if you like, on Jupiter. And part of that is being done by Juno coming very close and skimming over the surface of the planet every once in a while. So you can see the incredible detail that you can see when you're only a few tens of thousands of kilometers above the surface. These little flashes you can see every once in a while, they're lightning flashes in the storm systems of Jupiter. This is a time lapse taken over perhaps a few hours or so. So it takes a few hours for the spacecraft to pass Jupiter, and then it can take weeks or months to go further away from Jupiter and then come back for another swoop as it comes close. So the colors are enhanced, but essentially correct. It does appear to be bluish at the poles and reddish at the equator. Understanding what these colors are, understanding this storm system, understanding these white spots is part of what Juno and other similar spacecraft are trying to do. So again, the difference between what we are now able to get in terms of high resolution images compared to where we were a few decades ago is quite incredible. When we have a look at some of the images from Juno, it really does look like a watercolor left out in the rain. People are trying to understand what features like this are, this black spot in the center there. It's thought that what we're looking at is a vortex that's actually going into Jupiter. Perhaps stuff is being dredged up from lower levels and coming to the surface. Perhaps other stuff is diving down. It is certainly the case that Jupiter behaves differently at different altitudes, and these clouds are at different altitudes. So trying to understand this system is part of what these spacecraft are doing. If we have a look at a short snap here, this is just a short snap of one part of the Jupiter system, indicating just how complex it is. If we think Earth weather is complex, imagine how complex it would be trying to understand storm systems that occupy such vast areas, such vast dimensions. But the solar system, remember, is not just the sun and 8 planets. New Horizons is a spacecraft that's now exploring beyond Pluto. It went to have a look at Pluto and its neighbor Charon, its moon Charon. It's now going much further into the Kuiper belt, examining what's out there, these very distant bodies. And in addition to that, there are also about 300, well, over 300 moons in the solar system, all of which have their own particular characteristics. Here's just a tiny sample of them. Some are relatively large and spherical, a bit like our own moon there in the bottom right. Some of them are relatively small and not much. They are bigger than potatoes, but they seem to be potato-shaped. Once they get small, it's difficult to make them spherical. And some of them look distinctly like the Death Star. They seem to be like Mimas, one of the moons of Saturn. But if we have a look at some of the larger moons, there's Titan in the middle. You can see Titan is actually a huge moon compared to even our moon, which is large compared to most moons in the solar system. Titan is absolutely huge and has its own atmosphere. It has so much gravity. But interest these days is in the moons of Jupiter at the top there. The one on the left, Io, appears to be volcanic because of its proximity to Jupiter. But the next 3 of the Galilean moons, Europa, Ganymede, and Callisto, have garnered a lot of attention recently because it looks like they are ice on the surface but water below the surface. There is more water on these moons than there is on the Earth. So if life developed here in liquid water, and there's a whole load of liquid water up there, then again we ask the question, is it possible that life evolved on these worlds? At some point, we're going to find out. It might be quite a few years before we can answer that question, and then you, of course, have the question, how do you find out? Do you contaminate those worlds? Yes, sir?
I just wondered about time. I wonder why it's got an atmosphere. I know it's bigger than the moon. The moon hasn't got any atmosphere as far as I know. Is it because it has probably metallic center like the Earth?
It is probably simply down to gravity. If the gravity is strong enough, you can hold on to an atmosphere. If the gravity is not strong enough, it doesn't matter if you start with an atmosphere, you will lose it. So in other words, Mars doesn't have much of an atmosphere because it's relatively small. Earth has enough gravity to hold on to an atmosphere for billions of years.
Means nothing. Obviously,
Well, density is...
Iron is more dense and
What matters is gravity. Regardless of what's producing that gravity, gravity is what matters. An atmosphere doesn't care where the gravity comes from. The atmosphere just cares that gravity has a certain value. It doesn't care whether that's from rock or whether that's from iron. If the gravity is strong enough, you can hold on to an atmosphere. So with the icy moons, we think there's ice on the surface and water below. If there's water there, and there's lots of it apparently, is there any life up there? And that's precisely why there are now missions. The European Space Agency launched a couple of years ago the JUICE mission, Jupiter Icy Moons mission, and NASA have launched Europa Clipper to go to Europa to try and find more information about what these moons are like. Up till now, all communication with these spacecraft has been by radio. Spacecraft go millions, tens of millions, hundreds of millions of miles or kilometers and send the information back by radio. And that can be quite slow. It might be only bits per second or perhaps thousands of bits per second communicated from the spacecraft to a dish on Earth. But in principle, it should be faster if you use lasers, because lasers are much higher frequency. They're capable of much higher bandwidth. So why not send a laser back from the spacecraft, and don't pick it up with a radio dish, pick it up with an optical telescope. This test was done when the last spacecraft visited the asteroid Psyche, and the information was sent back to the Hale telescope, the 5-meter telescope in California on Mount Palomar. What test do? You don't just send a small image, because that's not a test of high bandwidth. You want to see whether or not you can send megabytes of information quickly. So instead of just sending an image, they decided to send a high-resolution video. If you're going to send a high-resolution video over a laser beam, what video do you choose? Of course, you choose a video of a cat chasing a laser beam. So they sent this test video of one of the NASA employees' cats chasing a laser beam, and they obtained data rates of 260 megabits per second. That's faster than some people get on their broadband when they're trying to download something from 2 miles away. And even when the spacecraft was 400 million kilometers away, they still got data rates of many megabits per second, thousands of times faster than what you can usually achieve with a radio signal. Therefore, in the future, now that it's been proved that the technology works, maybe future missions will actually have laser communication rather than radio communication, which means we'll get the data back instead of, for instance, New Horizons spending months and months and months sending the images back. Maybe we can get them thousands of times faster and hopefully at higher resolution. So let me finish by just saying that if you're interested in learning more, Cassini has now come to the end of its life. Bepi Colombo is on its way to explore Mercury. New Horizons, it's on its way out of the solar system. Juno is still looking at Jupiter for a little while. It's got a little bit left on its mission. And I've just said that the Jupiter Icy Moons, JUICE, and the Europa Clipper missions are on their way. So if you want to know more, go find out from these various web pages about what has happened and what will be happening in the near future. Thank you all very much.